So before you even start trying to work through your assignment, I suggest you wait until I do one example, because this one is a little bit different. It's something you probably have never seen before. Okay, so as a refresher, what a regular polygon is, that is when all your sides and angles are congruent. Okay, so in your figure, all your sides are congruent to each other and all your angles are congruent to each other. Okay, so the pentagon at the right is inscribed in circle A. So circle A is around the outside of that pentagon. Okay, so the center of the circle is also going to be the center of the pentagon. Okay, so the center point A is the center of that circle. It's also the center of the inscribed pentagon. Okay, then the radius of the circle, which is AR, is also the radius of the pentagon. Okay, so we're going to be looking at finding the radius of our regular polygons as well as another segment within it. Okay, so if you were to draw a circle around the outside, your radius will go from the center point to one of the vertices. Okay, so that is the radius. Okay, so now we have an apothem. Okay, so this is kind of a new word for you. So the apothem of the pentagon is the perpendicular distance between the center and the side of the pentagon. Okay, so from the center point to the side and perpendicular to that side is an apothem. And we label that as A. Okay, so it has to be that perpendicular segment to that side. And what you'll notice is that you create a right triangle with those two segments and half of that bottom segment there. Okay, questions so far? So for any regular polygon, the central angle is an angle whose vertex is the center, and the sides contain two consecutive vertices of the polygon. Okay, so your central angle is going to be between two radii of your polygon. Okay, so you have a radius right here. You would have another radius right here. Okay, this whole entire angle created between those two segments is called your central angle. Okay, so that entire angle created is the central angle. Again, it's between the two radii, not between the radius and the apothem. So the measure of each central angle of a regular n-gon is 360 over n, where n is the number of sides. Okay, so to find your central angle, you just have to take 360 and divide by how many sides there are. Okay, so that's your formula. So that's what we're going to start with in number 1. We're going to sketch a radius and the apothem, and then find the central angle for each regular polygon listed below there. So letter A, first I want to find the center. Okay, the center is also the center of the circle. So if you were to draw a circle around that polygon, okay, it's also that center point. Then I want to draw in the radius. So the radius goes from the center to a vertice. Okay, so that would be a radius of the square. And then I also want to draw in the apothem. Okay, that's straight down from the center and perpendicular to the side. Okay, last thing, I want to find the central angle measure. So to do that, I would take 360, divide by however many sides there are. There are 4. So your central angle is going to be 90 degrees. Now again, that's between your 2 radii. That's not this angle right here. Okay? 90 degrees has to be between these 2 segments. Okay, so this entire angle here is 90. Make sense? All right, I want you guys to do the last 3. Draw in each segment and then find that central angle measure. All right, I have each of my segments drawn in for B, C, and D. Okay, so I have my radius and my apothem for each. Okay, then your central angle measure, 360 divided by how many sides there are. This one has 8. Okay, so that central angle measure will be 45 degrees. Letter C is 360 divided by 3. That's 120 degrees. And letter D is 360 divided by 6. That's 60 degrees. Now, since your central angle is between your 2 radii, right, we can find this little angle here between our radius and our apothem. Okay, it's just going to be half of your central angle measure. So if my central angle for letter B here is 45 degrees, this angle between your radius and apothem would be half of that. Okay, so I could take 45 and divide it by 2. Okay, that's 22.5. Okay, so that angle right there would be 22.5 degrees. So that's the same for all the rest of these as well. So in letter C, I could take 120, divide that by 2, it's 60. So this angle between the radius and the apothem here would be 60 degrees. Okay, does that make sense? So we will need to know that in order to find the area of each of these regular polygons. So moving on to actually finding the area of a regular polygon. Okay, in our formula here, capital A is the area. Lowercase a is the apothem. This is an O. And then uppercase P here is the perimeter of the polygon. Okay, so to find the area, you do need the apitham and you do need the perimeter of that polygon. Okay, so instead of writing it like this, I usually write it as A times P divided by 2. Either way you write it is fine. Okay, so we are going to move into finding the area of a regular polygon. Now, in each of these examples, I do have each of the pieces laid out for you. Okay, so find the central angle, find the radius, find the apitham, find the perimeter, then find the area. Okay, so first thing I want to do here is label each of my sides. Okay, I'm going to do these in different colors just so it's a little bit easier to see. So your radius is this segment AB. Okay, so our radius is what I labeled in blue there. The apitham goes from B to D, so perpendicular to that side. Okay, and then to get the perimeter, we just have to add up all the sides around that regular polygon. So next, what I want to do after I label each of my segments is find the measure of the central angle. Okay, that's what we just did above here. Okay, so we're going to take 360 and divide by however many sides there are. Okay, there are 6 sides. So our central angle measure is 60 degrees. What does that make the angle between the radius and the apitham? 30. Okay, so this angle here is 30 degrees. So what I want you to notice is that you have this right triangle created, correct? Okay, you have this angle of 30 degrees, 90 degrees. This one has to be 60. What we can do to solve for the remaining sides is use our special right triangle rules. Okay, so those are these right here. Okay, they're over there as well on the yellow sheet. Now, before we do that, I do have this entire side, AC is 3 meters. I need this piece right here. Well, what this apitham does is cut this side in half. Okay, so this length from A to D is going to be 1.5. So now, in my little right triangle here, it is 30, 60, 90. Opposite the 30-degree angle is your short side. So I am given my short side. Okay, the radius is the hypotenuse. Okay, so I'm going to use this equation here to find the radius. That's hypotenuse is equal to 2 times the short side. And I'm just going to plug in what I know. Okay, hypotenuse is R. Short side is 1.5. Okay, so our radius is going to be equal to 3. Okay, so on that line that says radius, we can say 3 meters. Okay, next I want to find the apitham. Okay, that's the side opposite the 60-degree angle. That's your long side. So now I want to use this formula because I want to find the long side. Okay, so to find the apitham, we'll use the long side is equal to square root of 3 times the short. Okay, plug in what we know. Long side is A. Short side is 1.5. Okay, and yes, I will allow you to actually multiply that and round to a decimal. Okay, so multiply 1.5 times the square root of 3. I got 2.6. Okay, so our apitham will be 2.6 meters. Okay, next I'm going to find the perimeter of the polygon. Okay, well this side from A to C is 3 meters. Since it is a regular polygon, all of your sides are congruent to each other. Okay, so that means each and every side is going to be 3 meters. So since there are 6 sides, I can just take 3, multiply by 6. All right, so now that I have all of the sides, I can now find the area. Okay, using our formula here. Lowercase a is the apothem we found to be 2.6 times the perimeter of the polygon is 18 divided by 2. And I got the area to be about 23.4 meters squared. Okay, so again, first I found both the radius and the apothem. Again, I labeled those in different colors so you knew how I found the radius and then how I found the apothem. Okay, any questions? Okay, so we are just kind of applying what we had talked about at the beginning of the year with special right triangles to our regular polygon. If you need to, you can redraw that triangle on the outside just to make it a little bit bigger and easier to look at. But any questions on this problem here? All right, then we're going to do another one on the back. So number 3, we have a square. This time we're given the radius of that square. Okay, so we have the radius here. That's 7 centimeters. We have to draw in an apothem. Now, you can either draw it in this way towards the bottom, or I'm going to draw mine in this way, just so I know that my radius is still 7 centimeters, not the apothem. Okay, so label my side as A. Now this time I'm not given this side length, okay, along the side of your square. So I'm just going to label that piece right here as X. Okay, so we already have the radius, but we have to find the apothem and that missing side in that right triangle. So again, first thing I want to do is find the central angle. So we'll take 360, divide by 4. So our central angle is 90 degrees. So that means our angle between the radius and the apothem is 45. Okay. Next on our list here is the radius. Well, we were already given the radius length is 7. So I can just write 7 centimeters right away. Next, I want to find the apothem. Well, again, this is a special right triangle. Okay, it's a 45, 45, 90. That's the pink rules here. Okay, so I have hypotenuse is equal to the square root of 2 times a leg. So that's what I'm going to use to find A and X. Okay, so using hypotenuse is equal to the square root of 2 times a leg. Because what do we know about the legs of a 45, 45, 90 right triangle? They're congruent to each other. Good. So I'm going to plug in my hypotenuse. That's 7. And then you can either plug in A or X. Since I was solving for the apothem, I'm going to plug in A. And from here, I just want to solve for A. So I'll divide both sides by the square root of 2. And again, we're just going to put it in a decimal So you don't have to simplify. Take 7 divided by the square root of 2. And I got about 4.9. Okay, so our apothem is going to be 4.9 centimeters. Now, since our legs are congruent, that means this x value here is also 4.9. Okay, but that's only this section right here of our right triangle. In order to find the perimeter, we need the entire length.
Sometimes you just multiply that by 2.
So I can multiply that by 2 to get the entire length of 9.8. Okay, so now that I have one of the sides of this square, I can take that side length, multiply by how many sides there are. Yes, 39.2, and that would be centimeters. Okay, so now I have the apothem and the perimeter, so I can find the area. Again, your area formula is A times P divided by 2. A being your apothem, so 4.9 times the perimeter is 39.2, and that is divided by 2. And I got about 96.04 centimeters squared. If you just said 96, that's fine as well. Okay, so we can use these special right triangle rules when we're given these special angle measures, right? So there are problems where you're not given 30, 60, 90 or 45, 45, 90. Okay, so that would be our next example. So again, I'm going to do the same process to start out like I was before. So labeling my sides, right? The radius goes from the center to a vertice. Okay, so that's your radius. The apothem goes from the center and is perpendicular to the side. Okay, that would be this length PS. Okay, and again, I'm not given this side length here of your right triangle created. So I will need to find that in order to find the perimeter. So I label that as X. You can label it however you want. You could label it as Z, Y, P, whatever you need to. Okay, so from here, starting out again, find your central angle. So this one will be 360 divided by 5. Okay, that's 72 degrees. So then my angle between the radius and the apothem, divide that by 2. That angle then would be 36 degrees. Okay, since it is 36 degrees, you cannot use this. Okay, just because you see a 3 does not mean you get to use special right triangles. It has to specifically be 30, 60, 90. Okay, this is 36 degrees. So instead, what we can use is SOHCAHTOA. So we can use our trig ratios to solve for a missing side. So again, looking for our radius first, it was already given to us. That's 10 inches. Okay, so I can write 10 inches in right away. Next, I want to find the apothem. Okay, the apothem is on this side right here. Okay, so I do need to use SOHCAHTOA, and I need to use the side that contains a number, not a variable. Okay, that side is your radius or the hypotenuse of your right triangle. Now, since I'm solving for the apothem and I'm going to go from this angle 36 degrees. The apothem is your adjacent side to that angle. Okay, so this one is adjacent. Your radius is your hypotenuse. If I have adjacent and hypotenuse, which trig ratio do I use? Cosine. Okay, so I'm going to use cosine of the angle I went from, so 36. That'll be equal to that ratio of sides. So our adjacent side, the one next to is A, over our hypotenuse of that right triangle is 10. Okay, to get A by itself, we need to multiply by whatever's in the denominator so that it cancels out. So our apothem will be equal to 10 times the cosine of 36. So again, you can just enter that into your calculator. And I got 8.1, or about 8.1. Okay, so that's finding the apothem. Now there are two different ways you could find your x value. Okay, one way. You already know that we can use SOHCAHTOA, right? So if you go from your angle and you're trying to find that opposite side now, okay, and you're given the hypotenuse again, you have opposite and hypotenuse, you can use sine. Okay, so you're looking for the opposite, have your hypotenuse. So we can use sine of our angle is equal to our opposite side x over the hypotenuse 10. That's one way. Second way, you have two sides of a right triangle now after you found the apothem. It's 8.1. To find the remaining side in a right triangle, you can use the Pythagorean theorem. Okay, so either using SOHCAHTOA a second time, okay, with sine 36 equals x over 10, or you could use the Pythagorean theorem with 8.1, x, and 10. Okay, either way, this one you might get a little bit of a rounding error. This one will be more exact. Okay, I'm just going to use this one. So here I would multiply both sides by 10. Get that out of the denominator. So that x value is 10 times the sine of 36. To get x is about 5.9. Okay, so that is the length of RS. Okay, remember we need that entire length. So what do I do to get from R to Q? Multiply by 2. So take 5.9, multiply by 2 to get that entire length of 11.8. So that we can find the perimeter of our polygon. So we have 11.8 times our number of sides is 5. That's 59. Okay, then finding our area, again, using this formula here, we now have the apothem and the perimeter. So plug in your apothem as 8.1 times your perimeter is 59 and divide by 2. And I got 238.95. Okay, so for some of your problems, again, you can use special right triangles. Okay, if you'd rather just use SOHCAHTOA the whole time, that's fine too, because we're rounding those special right triangles with the square roots. But again, you can only use these two if this is specifically your angle combination or this is your angle combination. Otherwise, you do have to use SOHCAHTOA. Okay, and again, if you need to just redraw that right triangle so that it's not so cluttered here, redraw it larger on the outside, label it correctly, then use SOHCAHTOA. Okay, you should remember how to do both special right triangle rules and SOHCAHTOA as you go through this. Okay, any questions on problem number 4? Again, I tried to color coordinate what I was solving for each here. Don't know if that was helpful or not. All right, then